Now lads, find two values of k. So here's what happens, okay? We have a circle, like so. This circle is here, and then goes, we have, it has a certain slope value. We know that much, okay? And what these two, there's going to be two tangents, okay? And these two tangents are in the dotted red lines here. But you notice that both of them actually have the same slope, but they're both tangents, okay? So what we're going to do is we're going to use the distance formula. Do you remember the distance from the centre of the circle formula? So we're going to use x squared plus y squared plus 2gx plus 2fy plus c equals 0. From all of this information here, I can find the radius and I can find the centre of the circle in seconds, okay? So 2gx, g is going to be minus 2, f is going to be 4. The centre of the circle therefore is 2 minus 4 because it's minus g minus f. It'll also be known as x1, y1 in a second. Next thing I can find out is using the radius formula is that g squared plus f squared minus c. I can find out that the radius is minus 2 squared plus 4 squared and c is 10. So that's minus 10. And then what I find out here is going to be the square root of 10, which is, just leave it as root 10. Okay. Now, what these two tangents have in common is they have one thing in common. What they have in common is that their distance from the centre of the circle has to be the radius. So these two black lines here, they both have to be equal to root 10. So now we can use d equals ax1 plus by1 plus c all over the square root of a squared plus b squared. And we know that that actually has to equal root 10 because the distance to the tangents has to be the radius. Upon doing that, the main thing is not to get your c values mixed up. Your a value is 3, your b value is 1, and your c value is k. ax plus by plus c. Now you put them in your values, you're going to get root 10 equals the a is 3, so 3 times 2. B is 1 times minus 4, plus k, all over the square root of, where's b squared, a squared plus b squared?
3 squared plus 1.
3 squared plus 1 squared, which is going to be root 10, right? So root 10 equals 6. What's 6 minus 4? Just be 2, won't it? So that's 2 plus k all over another root 10. So here's what we're going to do. Multiply both sides. Root 10 multiplied by root 10 is 10. Now there's two ways of doing this and I'd like you to know how to do it both ways. First way of doing it is really simple. This could mean, remember what we said about modulus signs. The modulus of minus 10 is 10. The modulus of 10, also 10. So there's two different ways of looking at this. 2 plus k could be minus 10, or 2 plus k could be plus 10. K therefore could be minus 12, or k could be 8. Everybody happy with that? Second way of doing it is to square both sides. Square both sides and you get 100 equals 4. It's going to be 2 plus k squared, right? Yeah? Sorry? You don't understand it?
I figured it out last night, but I don't know what you do.
Okay, just let me go back to it after I finish off this way. I'm going to get k squared plus 4k minus 96 equals 0. I'm going to look for two numbers to give me a value of 4, so 12 and minus 8. K equals 8, k equals minus 12. Now, once somebody's asked me just about the shorter way of doing it. See, what modulus means is, if I had minus 25 in this, the answer is 25. And if I had 25, the answer is still 25. It just means take the positive value. Okay? So the way I picture this is, I picture that this is equal to 10. So I picture this part here can either be minus 10 or plus 10. Because minus 10 within the modulus signs gives you an answer of 10. plus 10 within the modulus signs gives you an answer of plus 10 as well. So all I have to do is write down 2 plus k will either equal minus 10 or it'll equal plus 10. And I get k equals minus 12 and k equals 8, which is the same answers as below. That's it. Okay. Shh. Okay, guys. Number 6, right? Number 6. It's actually the same thing, except there's 2 k's. So once again, we're going to do the same trick as last time. We're going to say that G is minus 5, F is minus 1, C value for the circle is 17. This hence means that the center of the circle is what's it, 5, 1 minus G minus F being the center of the circle, which is 5, 1, which will also stand for x1 and y1. I can find the radius using g squared plus f squared minus c. Radius therefore will equal minus 5 squared plus minus 1 squared minus 17. 26 minus 17? Square root of 9. Radius is 3. We know that the distance from here to here is 3. Now there's another formula that does the perpendicular distance of any point to any line. So we can find out the distance from the center to the line by using the D formula. D equals ax1 plus by1 plus c. But please remember it's the c on the line, not the c on the circle. And then it's a squared plus b squared. So we get a equals 3, b equals k, c equals minus k. We do exactly the same thing as last time. D is 3. What does say A and B were again? 3k minus k. So 3 times 5 plus k times 1 and c is minus k all over the square root of a squared, which is 3 squared plus k squared. So that modulus sign. Now, I do this, the k's cancel, don't they? So I'm left with 15 inside here. The modulus is 15 all over the modulus of 9 plus k squared equals 3. I'd be very inclined to square both sides this time. Why do I square both sides this time? K is stuck in the root. So I'm going to get 9 equals 225 over 9 plus k squared.
Is the modulus still there when you square it out?
No. So example, modulus of minus 10, square minus 10, you get 100. Modulus of plus 10, square plus 10, you get 100. So it has to be positive, so the negative value no longer applies. Cross multiply, we're going to get 81 plus 9k squared equals 225. 225 take away 81, guys. Anybody? What?
Minus 144.
144, yeah. Divide by 9. 16. K therefore equals plus or minus 4. And 0.2 k. Done. Okay, guys. So, find the equation of the tangents of this circle that are parallel to this line. When you're parallel to a line, what it basically means is you use the existing line, but you change this value here. That's the only value you have to change. Okay, does everybody understand that?
Yeah.
Okay, now it's like x plus 4y plus k equals 0. Now the reason behind that is I always use y equals mx plus c. That's just the way I interpret lines. If I did y equals mx plus c here, what I'd have is 4y equals minus x plus 3, divide by 4. I need a slope of line, I need a slope of a quarter. Does everybody agree with that?
Yeah.
Slope of a quarter. I can then change this value here for any value I want, and that will create a line that's just slightly in the same slope but in a different position. So I call it C for a minute. Then I multiply everything by 4 again, and I go 4y equals minus x plus 4c. Bring the x over to your side. X plus 4y is exactly the same as the one that came before it. Yeah? And then I bring the 4c over. Now this 4c is a number that I don't know. I don't even know what this number is. Yeah, would everybody agree with that? And what I can just call that is k instead of minus 4c. So that's why it still has a slope of minus a quarter, but it just has a different y-intercept position. Yeah, because c represents the y-intercept. So I just changed the y-intercept. Okay. So it's actually, now that we've modified it, it's exactly the same as question 1 and 6. Is that alright? So I won't go through that again. Now this one, however, I will go through every part of it. This one here, it wants it to be perpendicular to this line. Okay? And because it wants to be perpendicular to this line, I'm going to find the slope of this line using the equation of a line formula. So 4y equals minus 4x minus 5. Divide by 3, minus 4 over 3x, minus 5 over 3. Everybody agree that this has a slope of minus 4 over 3. Yes. The perpendicular slope therefore is 3 over 4. Okay? I'm now going to come up with the equation of a line that has, a slope of 3 over 4. Alright, so I'm going to use y equals mx plus c again. Y equals 3 over 4x plus some random value I don't know. Would everybody be alright with that? Multiply both sides by 4. 3x plus 4c. Bring it over to the other side. Minus 3x plus 4y minus 4c equals 0. What can we do with 4c? Just turn it into a plus k, because 4c represents a random number that we don't know yet, so we might as well just leave it as k. So I've now created a new line that is perpendicular to the old one. Now there is a shortcut for this if you want. Okay, the shortcut is, and some of you might have this learned off from if you have any, like sometimes Grimes does it this way. A quick way of learning it off by heart is exchange the k, put a k value in instead of the normal number at the end. Exchange the number in front of the x and y. So it's now going to become 3x plus 4y. Are you happy with that? And then there's only one other modification left. Change the x value. The x value changes sign. Is that right? That automatically makes it perpendicular. I know it from the minus b formula, so I never have to learn stuff off. And for the parallel line, you actually don't have to change anything. You just leave it as x plus 4y. Because it's parallel. These parts here are the parts that affect the slope. So then it just comes a k at the end equals 0.
Plus k.
Okay? Yeah. So if I gave you another random line like 2x plus 5y plus k equals 0, I want something perpendicular to that. Once again, interchange the x and the y values, and then change the x sign every time. But I personally think if you understand how to go back by doing the minus b version, by doing y equals mx plus c and then working backwards, you understand it that way. So it's not about memory. You know what I'm saying? But the other way is faster, and if you do have a memory, well then you might want to do it that way. Now, what we have here is we're going to work on these points here. We're going to get g is 3, f is minus 1, c is minus 15. Then we're going to get the point minus g minus f, which is the centre of the circle, is minus 3, 1. Upon getting the centre of the circle as minus 3, 1, I'm then going to find the radius of the circle using g squared plus f squared minus c. Or it will equal 3 squared plus minus 1 squared. Watch out for the minus minus. Gets a lot of people. R equals root 25. R equals 5. Happy enough with that. Now, what I have here is my diagram. I have a centre of a circle. Now, do you know the initial line it gave me? Yeah? The initial line could be a line that doesn't go through the circle. It could be a tangent itself. Or it could be a line that goes... It could be a chord, but it has absolutely nothing to do. The only thing it has to do with the tangent is that the tangent hits that line perpendicular. Okay, that's the only thing it has to do with the question. So when we re-look at our question, what we're doing is we're trying to find we're trying to find two lines that the distance from the centre of the circle to this is going to be 5, and we know the centre of the circle to be minus 3, 1. When you have information like that, you're going to go for the D formula. So D equals ax1 plus by1 plus c all over the square root of a squared plus b squared. Now, what's asking me this time is what's asking me to do is D is 5, A is minus 3 times, well, minus 3 plus 4 times y1, 1 plus k all over the square root of what, guys? What's square root of 3 squared minus 3 squared plus 4 squared? 25, isn't it? Root 25? 5. 5 on the bottom. That's 9 plus 4 is 13 plus k on top. Modulus. Bring up the 5. Turns to 25. Let's do the short way. I'm not in the humour for a quadratic. So 13 plus k equals 25. 13 plus k equals minus 25. K equals minus 38. K equals 12. Therefore, the two equations of the lines you're looking at here are minus 3x plus 4y plus 12 equals 0. And the second equation is minus 3x plus 4y minus 38 equals 0. Can anybody else give me two other answers that are acceptable? You know it, Fagan. Plus 3x minus 12 equals 0. And the other one? 3x minus 4y plus 38 equals 0. Always beware the minus 1 version of your answer. Okay? Blah blah blah. Okay. Rebel. Now, what we have here, guys, is we're going to look at number 18. Now, with number 14, the centre 0, 0. That's the only deal with 14. And the radius of 14 is the square root of 20. You happy enough with that? Alright. Once you have that information, it works exactly the same as 18. 18, I'm going to get 2gx equals 8x, g equals 4, f equals 3, the c value of the circle is 15. That makes this a centre of circle of minus 4 minus 3. You happy with that? Now, I have a random point. This random point is 1, 2. It could be anywhere. I'm just going to put it out here. Okay? Now, what happens with this one is that I could have two tangents coming from that point. That's technically a chord, but you get the gist. Actually, should do it this way. Yeah, that would have made sense. So you just draw it like that. Just come from the point back towards the circle. It's easier. You can see two distinct lines. Both lines have 2 minus 1, 2 as a point on that line. Would you be happy with that? And both points have different slopes. Both lines have different slopes. Yeah. You happy with that? Step 1. I'm going to find my radius value, like we've done the last couple of times. Radius value equals the square root of g squared, 4 squared plus 3 squared minus 15, or equals the square root of 10. You guys happy enough with that? Root 10. Now, upon getting root 10, we're going to use the D formula, like usual. ax1 plus by1 plus c all over the square root of a squared plus b squared. Now, what we're going to get here, guys, is we have no a, b and c value. Is that correct? We have x1 and y1, and we don't know what a and b are. Now here's what we're going to do. We're going to get the equation of a line, and what we know about this line is that it contains the points 1 and 2. Would you agree with that?
Yeah.
You agree with that? It contains the point 1, 2? We're going to do this. 1 minus 2 equals m into x minus 1. The problem is we don't know the slopes. There's two slopes and we don't know what they are. That's the problem. So what we're going to do next is we're going to say y minus 2 equals mx minus m. We're then going to put everything onto one side, and we're going to get 0 equals mx minus 1y minus m plus 2. I'm then going to rejig this into mx minus 1y. I'm going to put 2 minus m at the end. This is the equation of a line. Would you agree with that?
Yeah.
This equation of the line is in the form ax plus by plus c equals 0. A equals m, b equals minus 1, c equals 2 minus m. So I'll make a list. A equals m, b equals minus 1, c equals 2 minus m. D equals root 10. And we're going to have a, which is going to be m times, now the x1, is the x1 the point on the line, or is it the centre of the circle? It's this formula relating to distance is the distance from a point to the line. This formula here, see the x1 and the y1? It's always a point that's off the line, not on the line, because you're measuring the distance from a point to that line. So this point has to be a distance of the radius to the two lines we're looking at. Okay? So it's going to be m times minus 4 minus 1 for b, and it's going to be minus 1 times minus 3, and then c is 2 minus m. Then that's all going to be over the square root of m squared plus minus 1 squared. Now, going to be patient with this. What we're going to do is we're going to get root 10. We're going to get minus 4m. Everybody happy with minus 4m? There's another minus m over there, isn't there? Minus 5m. It's going to be plus 3 and plus 2, which gets me plus 5. And then on the bottom is the square root of m squared plus 1. The presence of the square root makes my life really easy. It means I should square both sides. When I square both sides, I'm going to get 10 equals, no, it's going to be minus 5m plus 5 squared, which is the same thing as, I'm just going to write the bracket down twice, just to make it easy for myself, all over m squared plus 1. I'm going to cross multiply the m squared plus 1 to the 10. It's going to become 10m squared plus 10. Then we're going to get minus 5m by 5m. 25m squared. Then it's going to be minus 25m minus another minus 25m plus another 25. We're going to make one massive equation out of this. It's going to be 15m squared when I bring that 10m squared over the other side. It's going to be minus 50m here. And then that 10 will join the 25 taken away from it. And that'll get me 15. I'll look down at this, I'll divide by 3, and I'll get, at 5 I'm in, 3m squared minus 10m plus 3 equals 0. I'll look at it and I'll do the reference number, 3m bracket m bracket minus 3 minus 1 equals 0. I now have two slopes as predicted. I have a slope of a third and a slope of 3. I reread the language of the question. The question specifically states the equation of the tangent, not just the slopes. So in order to do this, I relocate the equation of my line, which is located here. mx minus mx, sorry, I'll do it like this actually. 1 second. Now, there is there. Just bring that down the bottom, store it. So it's mx minus 1y plus 2 minus m. It's just a matter of putting in the equations. If I'm in a test, I'm going to start off with 3. 3 is easy money, no fractions. 3x minus 1y plus 2 minus 3 equals 0. 3x minus 1y minus 1 equals 0. That's your first equation. Your second equation is going to be a third x minus 1y plus 2 minus a third. Now 2 minus a third, I'm going to change that top heavy right away. It's going to be 6 over 3 minus 1 over 3. which is going to get me 5 over 3 equals 0. I'm going to multiply both sides by 3, and you're going to get x minus 3y plus 5 equals 0.